So this is joined with Pontus Rendahl, who's at Cambridge, and Marcus Riegel, who's a student at LSE. So there's been a bunch of projects that I've been working on, and they have the common theme. I'm interested in frictions in the goods markets and frictions in the labor market. So here the friction on the goods side is precautionary savings, that people may want to sort of consume less. And there's actually a whole bunch of papers who are interested in that. But very often is that precautionary savings cannot end up in anything that's productive. And over here in this paper we do allow for precautionary savings to potentially show up in something that is productive. So I'm going to talk a little bit about the algorithm. Part of that is older stuff that I've done with Pontus on explicit aggregation. But what we do here, what at least some people in the literature don't do that carefully, is we're going to carefully deal with the firm value when you have incomplete markets. And then I'll talk a little bit about model properties. So we're going to have precautionary savings and we're going to have sticky nominal wages. And so actually with the sticky nominal wages we're going to have this magnification through precautionary savings. But if you don't have sticky nominal wages, then actually precautionary savings are going to dampen the shocks. Okay, so the model is going to be a standard Mortensen-Pizarese type labor market. We're going to have heterogeneous agents with incomplete markets, and we're going to have nominal wage stickiness. Okay, so for the individual agent, is that he has no disutility of leisure, just like in the standard labor market matching model. If you're employed and you're going to get nominal wage WT, there's an exogenous separation rate. And in terms of the assets, the way they can insure themselves against unforeseen shocks, they can invest in money, and they can invest in firm ownership. Right? So one firm is going to be one entrepreneur and one worker. And so the number of employed people is the same as the number of firms. And they're owned. And so there's issues of equity. Okay, so first order conditions. This is the budget constraint. So on the top we have what they spend their money on. So it's consumption of agent I. So Q is the amount of equity that you buy. That's the nominal price. That's the amount of money that you choose. Over here I got the guy's resources. If he's employed, that's 1, he gets the wage rate. If he's unemployed, then he gets unemployment benefits. And this is his return on equity shares. He gets a dividend. And then he gets firm value, and there's exogenous separation. So it's the same rate for the worker as for the firm. And this is his money holdings at the beginning of the period. The guy cannot go short.
So he gets separation, the equity owner gets separation from...
So take a standard labor market matching model.
Yeah.
But with the setup is that each firm has one worker.
Yeah.
And there is an exogenous death rate for the firm.
For the firm.
Right. So a job is the same as a worker position over here. And so with probability rho x, the firm disappears, and then the worker gets fired, and the owner of the firm loses its value.
Wait, where is the owner? Is he a person in here or not?
Yeah, but he doesn't do anything. He doesn't.
I own the same firm that I work for, or I own a different firm, and someone else loses their job if my firm goes out.
Wait, say that again, sir.
Do I own the same firm?
No, of course not. No. Right. So is that you guys are all workers. If you go find a job, then that's a separate. That's a.
For Ken, and Ken works for Carl.
That's right. Right. So is that you as an investor, you choose, to invest in firms, but that's you don't invest in your own firm, which I think makes sense. I mean, it would be bad if that you get unemployed, and then also at the same time is that your ownership of firms is going down. Okay, so these are standard first order conditions. This is the first order condition for holding money. Right, so this is what you give up. This is the real return. This is the money in the utility part, and this is the first order condition for firm ownership. Okay. So this is really exactly the same as you have in a standard matching model. So this is the free entry condition. Right, so there's a potentially infinite number of entrepreneurs out there. So the cost of posting a... So we think of this as more than just posting an ad, right? So you create a job, and then part of being successful is having a good project and to find a worker. So there would be a flow cost of psi, so normal term is PT. So if you're successful, that happens with probability pi f, then you get firm value DAT. And then this is the probability of being successful, and that does depend on tightness in the labor market. So if there's more people trying to create jobs, so this is vacancies, then the probability would go down. And if there is more people searching, right, so employment is higher, then that probability would go up. And this is just the law of motion for, so this is the law of motion both for a number of people that are employed and for the number of firms. But, I mean, I stress a little bit more that it's also interpreted as numbers of firms, and that's number of equity shares, because we're more careful about the investment portfolio decision. But other than that, it's the exact same as in a standard more simplicity problem. Okay, so an existing firm, so these are dividends. So ZT is going to be the exogenous, and that's just aggregate productivity shock. So this puts us in nominal values, and this is the wage rate that's being paid out by each firm. So all firms are identical. Right? There's no idiosyncratic shocks hitting the firms. They have the same ZT, and actually they're going to have the same wage rate that they pay out. Okay, so often they choose something like a bargaining process to determine wages. We're just going to parameterize that, because we want to be careful about whether you have sticky real or sticky nominal wages. So the nominal wage that's being paid out by each firm depends on the aggregate productivity shock, and it depends on the price level. So if W1 would be 0 and W2 would be 1, then we would have sticky real wages. But if the price would go up, then the nominal wage would go up 1 for 1. But we're especially interested in this case where we have sticky nominal wages. And we also look at cases in between. But I mean, I've used something similar in my older work. So basically the idea is you're going to choose those parameters so that you get realistic processes for the wage rate. Because if you use something like Nash bargaining, the question is whether what you get out is actually somewhat realistic.
So this isn't like a menu cost changing, or that there's a sort of a movement towards the.
It's very ad hoc.
It's just sticky.
It's very ad hoc. So we just specify this thing so we get something that looks like what you observe in the data. But yeah, there's no deep sort of motivation for why you get this particular process. And it's a big debate whether wages are really nominal, sticky, and. Okay, and then equilibrium condition in words. There's going to be demand for money, and it's got to be equal to money supply, which today is going to be constant. And then there is demand for firm ownership. So this is demand for ownership by this population of agents that could become employed or unemployed, right? And so as part of ensuring themselves against being unemployed, they're going to demand for these assets. But so the demand for firm ownership, the number of equity shares these guys ask in equilibrium, got to be equal to the number of firms. And this is determined by the free entry condition. Right, so this part is the exact same thing as the standard matching model. But then this we have is because we have incomplete markets and guys trying to insure themselves. Okay, so that was the model. I mean, I went fast, but I hope you guys realize it's very simple.
One question: demand for, when you're speaking of a demand for firm ownership equal to any number of firms, that's sort of an asset pricing condition.
Yeah.
The prices of the firms change.
I mean, so if you think about it, I mean, this is the equation that's going to pin down P, and this is the equation that's going to pin down J, the value of a firm, right?
So it sounds like there aren't any people in this model other than the workers, because they don't also own any new firms.
That's right.
Okay.
I mean, so typically the way you tell the story, you say there's entrepreneurs, but the entrepreneurs, they don't do anything. They don't.
Yeah, well,
They basically they get the profits and that's being handed back to the household. But then, yeah.
But this is a more consistent sort of flow of funds kind of story. Is there are some pure profits. and
Yes.
Those don't go to some entrepreneur who knows where the hell they are. They actually go right back into the people that we're studying in the model.
That's right. So, I mean, so if this is the economy,
Yep.
and then, so you guys, you own money and you own firm ownership, and then over here there's a whole bunch of firms. So in the morning, all the guys who are employed, you go there, and in these firms they make profits, and that profit is, allocated back to you, depending on how much firm ownership you have. Yeah, but you don't really worry about who's running the firm, because typically speaking, I mean, the worker is just running the firm by himself, and then so
Well,
he
there's not much to run other than just show up.
yeah, that's right. Yeah, because I mean, you just get that,
Yeah.
and it's being sold, and then, but there is this dividend, and that just goes to the owner of the firm. Okay. Okay. So the algorithm. So we want to deal correctly with firm value when you have incomplete markets, and then I'll explain expo a little bit. And then you'll see is that we're going to solve this model with surprisingly few state variables. Okay, so so we had this Euler equation for the individual agent, right? So there's a subscript I over here for the marginal rate of substitution. Now these are aggregate variables. All the firms are the same, so dividends would be the same. And then of course, so typically what people want to do, if they face an equation like that, they want to put a marginal rate of substitution there, and then you're going to solve for j from this equation. Right? So for example, you have something recursive, you have a guess for j, you calculate the conditional expectation, you got a new j, you iterate on that, or you just you try to solve it. But over here, we got one of these equations for every agent. Okay, so what people do in the literature, well, if you have a representative agent, you just pick the marginal rate of substitution of the representative agent, and then it's easy to find the j. Now there's papers that have an equation like that, when then just like in our setup you have heterogeneous agents. And then, so one nice solution is by Crucell, Mukiyama, and Sahin, and they have for the aggregate state Z only two outcomes. And so then they also have two assets, so then you can actually use the prices of the two Arrow-Debreu securities to price the two possible outcomes for the return for the firm. And then a whole bunch of people, they actually make dinky assumptions. They assume is that the firm is actually risk neutral. Right? So the guy who actually posts the vacancies is that he's risk neutral, so then you can ignore this. But if you think about it, it's actually not that difficult to do this right. And as we're going to solve for j, we're just imposing the equilibrium condition. So you think people in literature, they've just fixated with that equation, which is the natural thing to look at where you're in a representative agent framework. So basically you say is that, well, what's the value of a firm? Well, the value of the firm is just the net present value of all the dividends. And then you're going to focus on an equation like that just to solve for j. We're going to get j by explicitly imposing equilibrium.
Now I look at that, so that equation with the question mark over it, that is an equation in your model.
Yeah, but we have many of those equations for every I.
Well, you have one equation for every I.
Yeah.
Okay. So it is an equation.
Yeah, I mean, it's
a lot of equations.
I know. So first, actually, I didn't have the I here, and then it's still the question mark.
Oh, yeah, okay, yeah.
But yeah, I mean, it's absolutely true. It's that, so in the model, we have that equation holding for every agent.
Yeah, there's no corners here.
The
The agent's always on the interior.
No, it's just that they may want to go short.
They're not allowed.
And they're not allowed to do that. And they're not allowed to do that.
They want,
They may want to go short
yeah.
in this asset.
Well, the only the Q.
So it's,
Yeah, okay, they're never gonna go short in the end.
that's right, exactly.
Because there's an anodic condition there.
Exactly.
But, okay, so then you don't have an equation there. You have some,
Yeah, you have to Kuhn-Tucker conditions.
yeah, okay.
That's right.
Okay.
But I mean, the idea was more is that in the literature, they actually try to price j exactly from an equation like this.
Yeah.
And then that's why I had the question mark. But okay, so Very good. So exactly. So that's the so now let's think about what we do. Is that the objective of the firm is maximizing firm value?
But why? Expected value. There is risk.
No. Okay, but so the hard so the hard question is literature as always is that if you say something like, well, maximizing what's good for the owners, then you got to know what this marginal substitution is, right? And so what we basically say is that you want to maximize that firm value.
Now that's an assumption.
That's an assumption.
Because now there are these diamond conditions that we want to go out, even when markets are incomplete, that is still the correction. That is the equilibrium objective. But we're not that far away from it. This is an assumption. Yes.
Okay, so basically what we do, again, think those two sides of the market. So on the one side is that, so suppose I tell you this is J, J is 12. Then from the free entry condition, we get is that the supply of the number of firms. Because J determines what the tightness is going to be, and so that determines the number of vacancies. And then with the law of motion for the number of firms or the number of employment, then we get the supply of the number of firms. But the way we wrote up the problem for the agent is that J will also affect the total demand by consumers. So we just solve for the J that satisfies that equilibrium condition. That the total demand of all agents for Q, which is firm ownership, is equal to the N that comes out of the free entry condition. And it's actually, it's quite simple. So anyway, so that's how we deal with J. So this is expa. Okay, so for those of you who don't know it yet, I'm going to explain the idea. I'm going to change notation, so because things are a little bit different for this particular problem, and it's a little bit easier over here. So suppose the state variable is little k for the individual agent, right? So this is the state variable for the individual agent, agent I, and that depends on. So this is his choice, and so this is the level he has now, and then S is the aggregate state. So we allow actually the constant and the slope coefficient to depend on the aggregate state in any arbitrary way. And then, of course, if you want to get the aggregate law of motion, if it's linear, it's trivial. And you just aggregate. So, you guys.
Now, S includes the whole vector of little k.
No.
Okay, so you've got some aggregation.
It's any aggregate state that you want. So typically what they do is that. So you start with. Okay, let me say. So the idea is over here is that. So what has to be in ST? So you start by saying is that the aggregate productivity should be there.
Yeah.
And possibly other things. Okay, so now what you see over here is that if you aggregate, you see is that aggregate K is going to be a state variable.
Yeah.
So you know is that ST is the aggregate productivity shock and KT. And over here you see you don't need anything more. But you guys didn't need me to tell you that. Right? So if the policy function is linear, then the only aggregate state that you're going to need is aggregate K.
That's Gorman aggregation.
Yeah, it's trivial. Okay.
Which isn't going to hold here.
Wait. I'm saying conditional on this. Right? The only thing I say is that if the individual policy rule is really this, then that holds. I haven't said anything more than that. Okay, so now let's go to higher order. So suppose the individual policy rule is quadratic. Right? So the same setup. So it can depend on the aggregate state variables in an arbitrary way. I'm going to do the same thing. I'm just saying, let's see what happens if I aggregate. So if I aggregate the individual policy rules, well, I get the constant back. I get the aggregate capital store back. And now what I would get is another aggregate variable, which is the average value of ki square. Yeah. So now this is that if you would ask me what should be in ST, should be the aggregate productivity shock, should be the mean level of k, and it should be the average of k square, which I write like this. Okay, well, if that's a state variable, I need a law of motion for it. Yeah. So how do I get a law of motion for the average value of k square? Well, One approach would be, well, I have a law of motion for ki, so I also have a law of motion for ki square, which is this. I just square the law of motion for ki. And then what I would get is that the average of that thing squared, is this thing. And if I don't work that out, you're going to get that the average value of the third order moment, the average of the third order term and the average of the fourth order term are state variables too.
Yep.
And of course this thing never stops. Right, so even if that coefficient is tiny but non-zero, you're going to have this problem, is that you basically need all moments. Okay, so how are we going to break this? We say, well, instead of using this law of motion for ki square, we're going to come up with a separate approximation, namely this one. So we basically say is that we're going to project ki square on the exact same set of variables. So we're going to skip the higher order ones. So these coefficients over here are now just new coefficients. They're not directly related to the ones we got from the linear policy rule. I'm going to basically say is that, so what's the projection of ki square on this basis? And now we're going to aggregate, is that we're going to get this. And we're not going to get any more state variables. And so, with this trick, is we're only going to need the productivity shock, the mean of k, and the mean of k square. Now it's important to understand is that this approximation that we do is we only need that to get the aggregate policy rules. Because actually what we're going to do in the algorithm is that we're going to have a piecewise linear policy function for the individual state variable, but we're going to say, well, but let's take a first order or a second order approximation of that thing if we need to calculate the aggregate law of motion. Right? So this approximation that we do, right? So we only need to get the aggregate laws of motion. So the individual problem we actually calculate quite carefully. So that's what I had over here. So the individual problem we calculate very carefully, we think. But then when it comes to calculating the aggregate laws of motion, is we do this trick of having a low order approximation of that thing. And then we get the aggregate laws of motion by explicitly aggregating those simple low order approximations to the individual policy function.
But if you had people distributed across a very wide range of values of k, corresponding to the fact that in microdata there's a very wide distribution of wealth in the population,
Yeah.
you're going to get different people at very different values of the marginal propensity to consume or
Yeah.
the structure to consume. So this will only work basically if everybody is near the same level of wealth.
Well, I mean, okay, so the question is, okay, so this is the policy function and this is the individual state variable. Okay, so it's going to look something like that. Then, so if you take something that's linear, so we're going to say now remember is that we're never going to say is that the individual policy functions are really going to look like this. But you would think if I have something like this and I got mass here and I got mass there, then saying is that the aggregate laws of motion, you can get those by explicitly aggregating something linear. That's not going to do a good job.
That's not necessarily true. In fact, I think the reason that it does actually work, which I think it does, is not because there aren't people in those areas where you said if there's mass here it won't work. There are people in those areas, but the number of people in those areas doesn't change very much. And so the answer that you get to them is absorbed in a constant term, and you're sort of approximating around the mean, which is changing.
Well, I mean, okay, so I think what you say is right, but since we actually take the approximation, the linear approximation, right, of that policy function here, is that the bias that we really get the bias that you mentioned. Now, what we did when we actually wrote down the paper on this method, we said if you have a bias like that, you can correct for that, because that bias is the same with aggregate uncertainty and without. Right? So then you can, because you're exactly right, that bias is constant, and then so it's just a matter of switching that function up and down. Okay. Okay, so now, so actually for this model, a first order approximation for the aggregate laws of motion work actually quite well. So then the only state variables that we have, so for the individual we have cash on hand, right? So that's the value of his equity shares, and his nominal amount of money, his employment status, and then the only aggregate state variables is the aggregate productivity and the number of firms. And remember, the number of firms is equal to employment, is equal to the equity shares. Right? So this n variable over here captures a whole bunch of things. Okay, so now, so that was the algorithm. So now a bit of economics, so precautionary savings. So how do you get precautionary savings in a model? Well, if you're lazy, you do it through beta. And so here we're going to do it through changes in unemployment. Right? So if unemployment goes up, there's some consumption smoothing going on too, but since these states are persistent, if unemployment goes up, is that you're more worried about unemployment in the future, and you want to insure yourself against that. Oh, ooh.
Very sensitive. Okay. So your precautionary savings is generated by the possibility that the aggregate unemployment rate moves up.
Exactly.
Not that you're saving in case you lose your job.
Well, okay, so in this model, the separation rate is exogenous. Right? So this still is precautionary savings in the sense that if you exogenously lose your job, it's going to take a longer time before you're going to be employed again if you're in an aggregate bad state.
Yeah.
I mean, with endogenous separation, is that you get the effect a bit quicker. Is that the chance of losing your job is going to be higher.
Okay. There's endogenous separation?
No, it's not. But
okay, this is exogenous separation.
but there is an endogenous chance of finding a job. So if aggregate productivity goes down, then firm value is going to go down. If firm value goes down, is that there's less vacancies being posted, and that means that the guys who are looking for a job.
So it's endogenous to the economy. It's not endogenous to the individual.
Absolutely.
Okay.
I mean, but if unemployment goes up, is that I mean. To really talk about precautionary savings, it'd be nice if you do mean preserving spread. So over here, we're mixing these two aspects. Okay, but so the typical story is that households want to save more, and so that means demand for consumption is going to go down, and if for example, if prices do not adjust, then the demand for labor will go down, and then sort of you can get a downward spiral. But then. So over here I said, well, people want to save more and consumption goes down, but where do these savings end up? Right? So typically in these models they rule out that it could actually end up in something that's productive. Or is that when it comes to valuing firm ownership, they don't allow is that because precautionary savings like the marginal rate of substitution is going up. You care more about getting stuff in the future. So that should have an upward effect on firm ownership. But if you don't discount correctly, then you're not going to capture that. Okay, so what do we have? We have something that's exactly like in the standard model, or in the standard story. If unemployment goes up, then people are going to say, I want to have more of that liquid asset, money. That's going to push down price levels. That's going to reduce profits if I have sticky nominal wages. And if real profits are going to go down, then there will be less firm and job creation, and then I'm going to get this spiral. But in this paper, we explicitly allow for the possibility that if agents are worried about becoming unemployed in the future, and precautionary savings are going to go up, it could end up in more firm ownership. And that's good for the economy. And so the question is, if you allow for this other channel, shouldn't that mean that precautionary savings is not bad, what we typically think is actually a good thing for the economy? People want to save more, they invest more. In the next period, you end up with more capital, or over here, more firm ownership. Okay, sorry. Let's just think in terms of what happens to output. I mean, I got to be careful in terms of welfare, but right. So the standard story is precautionary savings is actually going to generate a downturn, or it's going to magnify the downturn. But so here we ask the question, well, but if the precautionary savings could end up in something that's productive, then maybe output doesn't go down. Output could even go up because, they want to save more, they save more in capital or firm ownership.
But there's no physical cost of capital here. There's no
Yes, sorry. No, sure, there is.
Oh, psi is a cost?
Yeah.
That is borne by the worker when he decides to start a firm. Okay.
No.
But
So, I mean, just
psi is a cost. Oh, psi is a cost, but it doesn't come out of any current cash flow. It comes out of. Well, where does it come out of?
no, I mean, so over here, a firm is really the same like capital. So you got to give up some real consumption units to start a firm. It's going to cost you psi,
Okay.
but there is free entry in that marker.
Yeah, free
Yeah.
entry, that's fine. I just did not see psi coming out of his consumption directly anyway. But that's in the queue, I suppose.
Okay, so the entrepreneurs is that, so they pay the psi and then they get the J in return. Right, so this is process of creating firms,
Yeah.
and the cost of that is the real cost. It's the real cost in goods that they give up.
But I didn't see a minus psi in the workers' budget constraint. I saw some Q thing, but
Yeah.
well, no, but it should show up in the budget constraint somewhere.
Yeah, but not of the individual agent. Yeah, I mean, you're absolutely right. But in the budget constraint for the economy as a whole, it will definitely show up. Okay, so now, so over here we have this economy, and these guys are worried about the future. So the marginal rate of substitution is going to go up. So will that mean is that there will be more investment in firms? And there's two reasons actually why that doesn't have to happen. So one reason is that profits are going to go down. So if the upward effect on the marginal rate of substitution that people are worried about the future is being dominated by the downward effect on profits, then J will go down. The value of a firm will go down, and then less vacancies will be posted, and indeed less firms will be created. But the other aspect that's there is that if agents have a higher chance of becoming unemployed, then they're less willing to hold risky assets. So there's a portfolio shift. Okay, so I have a very simple example to make that clear. So it's just 2 periods. So the guy is just maximizing the utility over those 2 periods, consumption in the first period, consumption in the second. So he invests in something that's risk-free, M, and A that's risky. And so the next period he's going to have income Y2. And over here it really is going to be a mean preserving spread. But the expected value of Y2 is always 1. And the risky asset is either going to be high or low. And I picked these 2 numbers such that in the case in which Y2 is non-stochastic, is that savings is exactly equal to 0, just to normalize things. Right, so in case 1, there is no unemployment risk for the next period. And then I chose the numbers such that aggregate savings is exactly equal to 0. And then actually he wants to go short in the risk-free, and he goes long in the risky asset. Okay, so now what's going to happen if I make that stochastic? I put a mean preserving spread on this. And it's a bit extreme. Y2 can be either 0 or 2. Now what's going to happen is that, not surprisingly, aggregate savings is going to go up. Right? There's more uncertainty the next period. The guy has concave utility, so he wants to insure himself against that. So he wants to save more. That's not surprising. But what's interesting, he really wants to get out of the risky asset. So there's enormous portfolio shift. Right, so in our setup, even though the guy has, right, the opportunity, if he wants to save more, to actually do something that's good for the economy in terms of, just adding up goods, is that he may not want to do that. Okay, so now I'm going to give you a couple more slides with results. So first case, there's no nominal wage stickiness. Okay, so now what I'm going to look at is we're in a good state, and then we're going to just move to a bad state. Over here is just 2 values for Z, just to keep things simple. And so productivity goes down, and it's persistent. So you expect that productivity is going to be low for a while. Okay, so profits are going to go down, not surprisingly. Firm value is going to go down, and it means unemployment is going to go up. Markets are incomplete, so precautionary savings are going to go up. Okay, now demand for firm ownership may go up, is because the unemployment rate is going to go down. People have less funds. The demand for money is going to go up, so then we're going to get the effect that I mentioned, is that prices are going to go down. But this will not have an effect on profits, because wages just adjust for the change in P. Right, so the fact that people want to hold money, that has a downward effect on prices, but that does over here, it does not affect profits, since I do not have sticky nominal wages. Okay, so what do we have over here? So this is the impulse response function, so this is time. So I'm in a good state, and then we move to the bad state. So it's like a supply shock, so prices are going to go up. Over here, we got 3 lines. So red is the representative agent, and then UI is the amount of unemployment insurance given. So here what you see is that if you have less unemployment insurance, then the precautionary demand is more important, and so there is more demand for money if times get worse, and that means is that more demand for money means a lower price level. Okay, so that lower price level doesn't seem to do anything in terms of firm value, but what you see is that firm value actually drops, the smallest amount if I do have this precautionary savings motive working for me. Right, so in all these cases, since this is the direct effect of Z, profits are going to go down, so firm value is going to go down. But the precautionary savings motive, that the marginal rate of substitution is going up, actually does push firm value up a little bit. I mean, it's quantitatively not very big, but it's there. And so, that translates into a somewhat higher level of N, right, of employment. So over here you see is that the precautionary savings actually work in the opposite direction that we typically think it does. Okay, but this is if there's no nominal wage stickiness. Right, so here the precautionary savings is a bit of end up in money, but the other part ends up in demand for firm ownership. And this extra demand for firm ownership actually dampens the downturn. Okay, so now let's look at nominal wage stickiness. Okay, so we got almost the same channels. Productivity is going to go down, so profits is going to go down. Firm value goes down, and employment is going to go up, then we get precautionary savings going up. Okay. if the marginal rate of substitution goes up, the demand for firm ownership may go up. Right, so we still have the marginal rate of substitution, that pushes up firm ownership. And then, so that would dampen, right, the increase in unemployment. But now let's go look at the demand for money effect. And we know is that demand for money is going to go up for two reasons. One is, precautionary savings goes up. It probably ends up in both. And there is this allocation, is that people prefer the risk-free asset over the risky asset. So P is going to go down. But now, if P is going to go down, and nominal wages are sticky, that means that profits are going to go down. And if profits are going to go down, then unemployment is going to go up, and I am going to get this downward spiral.
Well, you say spiral, but
Well,
with the bottom or not?
Yes, what?
With the bottom or not?
Yeah, yeah. I mean, you'll see.
It's stable.
Okay, so now what happens is that if I don't have good unemployment insurance, the precautionary savings is so high, and then it goes through several rounds. But yeah, I mean, at some point it settles down. Is that then the price level is a lot lower. Whoops. And so firm value drops a lot more, and employment drops a lot more too. And that's it. And I'm only 1 minute over. Okay, so right, I don't have a concluding slide, but right, so the punchline is that we do allow, right, precautionary saving to end up in something that's productive. It turns out that that's not where it's going to end up, right? And so that's an endogenous result of the model, and there's two reasons why it doesn't end up there. So one is that the profit effect can dominate, right, the marginal rate of substitution effect, and that will happen, right? That's more likely to happen with nominal sticky wages, because then the precautionary demand for money, right, is going to reduce firm profits, because precautionary demand for money is going to put downward pressure on prices, and so if wages don't go down, it's going to reduce profits. And the other thing is there's a portfolio shift, right, out of the risky asset into the risk-free asset. That's it.